Hi everyone, good morning. So today we're going to learn about work, power, and energy. And here are our learning targets for today. After today's lesson, you are able to define what is work and power, understand what is mechanical energy, and determine the factors affecting kinetic and potential energy. So let's proceed. What is work? So we already discussed what is work, and we know that work is done when a constant force is applied on an object and causes that object to move in the same direction as the force applied. Hence, I have an example here. Okay, looking at the box, it moves in the same direction as the force applied. So what are the values that we need in order for work to exist? So we must have force and then the object must be moving. So therefore, our formula for work is force multiplied by its displacement. So the unit of measurement for work is joules, while for force we have newtons, and for displacement we have meters. So we have two factors only to know that work exists. Okay, so we have first when the object is moved by the force applied and when the direction of force and motion is the same. Okay, so those are the two situations that we can say there is work. So I have here two examples, a man pushing a pushcart and another person carrying a box. So which of the following example is work done when we can say that there is work done? Okay, remember, work exists only if the object is moving uh, and when the direction of that object is the same direction as the force applied. So let us see. So for that person who's pushing the push cart, the force applied is moving is towards the right. And then the push cart is also moving towards the right. Hence, we can say that the person pushing the push cart, there is work. Okay. So for the other example, the force there is upwards because that man is carrying the box. Okay, so let us see the force, the direction of the motion. The direction of the motion is going towards the right. So the force and the motion is not in the same direction. Hence, we can say that in this situation, there is no work done. Okay, so for here, there is work, and here, there is no work done because the force and the direction of motion is not the same. Okay, I hope you already understand that. Okay, let's proceed. What is power? So we already discussed power. Power is the rate of doing work, or should I say it's how fast we do work. We also know that power is the amount of work applied to an object per unit of time. So I have here an example. Looking at that stick man pushing a box, he exerts a force and then that box moves in 5 meters towards the right. And then he finishes that in 3 seconds. So to calculate power, we must have the following values: work and time. So the formula for power, we have work over time. So remember, power is the rate of doing work. So that is why we have work over time. The unit of measurement for power is watt, and for work, okay, we remember that work is joules, and then time. The time should be in seconds. So hence, we have the formula for power. Power is equals to work over time. Okay, so let's proceed to energy. What is energy? I have here an example. A lady pushing a cart, or um, is there energy involved there? What is energy? Okay. In physics, energy is the quantitative property that must be transferred to an object in order to perform work. So, um, that means it is the capacity or the ability to do work. So, you must have energy to be able to do work. Okay. So, energy, when we say energy, the ability to do work, this means that energy is being transferred by a force when we move an object through a distance. Therefore, work is a method of transferring energy. So, have you understand that? Okay? When we say energy is the ability to do work, that means we are transferring energy by a force that moves an object through a distance. That's why I have here work is a method of transferring energy. You must have energy in order to do work. Okay? Yeah. So energy has different forms. We have thermal energy, we have radiant energy, nuclear energy, mechanical energy, electrical energy, sound energy, and chemical energy. So those are the different forms of energy. They exist in different forms. But for today's discussion, we will focus on mechanical energy or motion. So mechanical energy is the energy that is possessed by an object due to its motion or due to its position. In physics, we have another term for that. Mechanical energy is the sum of potential energy and kinetic energy. Therefore, I have the following formula for that. So mechanical energy would always equal to the sum of the kinetic energy and the potential energy. Therefore, mechanical energy exists in two forms, kinetic and potential. So, mechanical energy exists in two forms. We have kinetic and potential. So, what does kinetic energy and potential energy mean? Okay. So, kinetic energy is the energy of an object because of its motion, or the energy of moving objects. It is a form of mechanical energy that is present in moving objects. So when something is moving, it has kinetic energy. Okay. Just like the person running here, he has kinetic energy because of its motion. So what are the factors affecting kinetic energy? So these are the following factors: the mass of an object and the speed of an object. So these are the factors that would affect kinetic energy. Therefore, we have the following formula for kinetic energy. So in order to solve for your kinetic energy, we must have the values, the mass, and the speed. So for the formula, we have 1/2 is multiplied to mass times the speed squared. Sometimes we can convert that formula into this one so that you won't have any difficulty in solving. So, kinetic energy is equals to mv squared over 2, where m is the mass of an object, v is the speed of an object, and squared. So, what does this mean? This means that when we increase the mass of an object, the kinetic energy doubles. Okay? So if there is an increase in mass of an object, the kinetic energy also increases. And when the speed of an object is increasing, the kinetic energy of that object will also increase. Okay? So those are the factors affecting kinetic energy: mass and speed. So for example, we have um, a car and a bike. Which of the following has more kinetic energy? When we look at the objects, the car has more mass than the bicycle, right? Therefore, the car has more kinetic energy. And when the two objects start to move, the car has more speed. Okay? It will run faster than the bicycle. Therefore, the car has more kinetic energy than the bicycle. So I hope you have understand this. These are the following factors affecting kinetic energy, the mass, and the speed of an object. Let's proceed to potential energy. So potential energy is a form of mechanical energy that is possessed by an object at rest. So I have here a person on top of a hill. He has potential energy. The other person who was running earlier has kinetic energy. Okay, so more about potential energy. Potential energy is a stored energy by an object due to an object's position above the ground. Okay, so what are the factors affecting potential energy? So we have the mass of an object and the height of an object from the ground. So these are the following factors that would affect potential energy. Hence, we have the following formula for potential energy. We have mass, um, mgh. M is for mass. G is for acceleration due to Earth's gravity. That is a constant. We already know that that is equivalent to 9.8 meters per second squared. And then we have h for the height of an object from the ground. So we have the following formula for potential energy. So mgh, mass, acceleration due to Earth's gravity, and the height. So these are, as I said earlier, these are the following factors that would affect potential energy. As you can see, G is a constant. That's why it would not affect potential energy unless we transfer to a different planet. Okay, so that would change. But we're staying here on Earth, so this is a constant. So the factors that would affect potential energy are mass of an object and the height of an object from the ground. So that means the bigger the object, the bigger the mass, the bigger the potential energy. Okay? And the higher an object from the ground, the bigger the potential energy. Okay, so I hope you have understand that these are the different factors affecting potential energy. The mass of an object and the height of an object from the ground. Okay, let's proceed. So we have here the law of conservation of energy. I hope you have already heard that, but in case if you haven't, this law states that energy can neither be created nor destroyed. Rather, it can only be transformed or transferred from one form to another. So this means that we cannot create energy. Okay? So that a system always has the same amount of energy, that energy is converted into several forms, but the overall energy does remain the same. So the law, when we say law, it means that it is based on facts. We have evidence and proof of this phenomenon. Okay, so the law of conservation of energy states we cannot create energy. Instead, energy can be transformed into different forms. But I have here that a system will always has the same amount of energy. It can be converted into several forms, but the overall energy of that system will always remain the same. Okay, so how is that related to mechanical energy? So I have here an example. A person on a bathtub. Yan. Nahulog siya. Okay. Another please. Yan. So here on the top, he has potential energy because the object is not moving. And when it moves, it has kinetic energy. Therefore, the potential energy is being converted into kinetic energy as it goes down. Okay. Another example for that is this one. Okay. A rolling ball on a hill. As you can see, when it turns blue, it has kinetic energy. When it turns yellow, it has potential energy. So the ball has kinetic energy when it's rolling or it's moving. But when it momentarily stops here, it has potential energy. And then that energy is being converted again into kinetic energy. So the energy is being transformed into different forms. Okay? So I have here another example. Okay? A cart, okay, moving up and down. So as it moves, it has kinetic energy. When it stops, it has potential energy. Okay? Potential energy due to gravity, kinetic energy due to motion. Ayan. So, makita ninyo, we have potential here and then full kinetic energy here. Okay? So, there is conversion of energy. Walang nawalang energy. It is only transformed into different forms. So, from kinetic, naging potential. Then, from potential, we have kinetic energy. So, I hope you understand what is work, power, and energy. So thank you all for listening today.